Hey everybody, Mr. Quick here. Today we're going to be talking about Eureka Math / Engaged New York Math, Module 3, Lesson 6, Rational Numbers on a Number Line. Before we get started, I'd like to do a quick little review that I think will help us with some of the problems today. If we have a fraction, let's say 1/2, or even let's say 4/5, can we turn those fractions into decimals? Well, if you said, sure we could do it a couple of different ways. You're correct, obviously, right? So we know if we want to make it a decimal, we're looking at another fraction that would have a denominator of 10 or 100. We can go either way, right? So 2 to get to 10, the constant or the magic number is going to be times 5. 2 times 5 is 10. You got to do the same thing up here. 1 times 5. 1 times 5 is 5. And we have 5/10. Now we know that 5/10 would be a 5 in the 10th place. If it helps you to do it out of 100 because you're kind of thinking of percents, add a 0 to each one. But still, if you made that 0.50, you know you can take that away and take the 0 away and make that 0.5 because they're equivalent. Over here, do the same thing. 4/5, we could multiply times 2 and end up with 8/10 and know that that's 0.8. Other way we could do it then would be to divide 4 by 5. 5 does not go into 4, so it goes 0 times. We end up with 0, we subtract, we get 4, right? We add a decimal and a 0. We have the decimal up top as well. So now 5 goes into 40 8 times. 8 times 5 is, bring that 0 down. 8 times 5 is 40. We subtract, we get 0, so we get 0.8. So two ways of doing that. That's a quick review. I want also to go the other way. If we had a decimal, such as 0.40 or 0.42 of 42 hundredths, right? Or even over here we can do 3.75. We'll do two different ones, right? 0.42, we know if that's 42 hundredths, because it's the number 42 and it ends in the hundredths place. Only thing we have here when we look at that as a fraction, we know those are both divisible by 2, so we must divide, and we're going to end up with 42 divided by 2 is 21, 100 divided by 2 is 50, and there's nothing left to divide here, so 21/50. On this side over here, we can look at this as 3 and 75 hundredths, right? Because we have a whole number. And that would be our answer, except we can still simplify this because those are both divisible by 25. I always, when it comes to 75, 50, 25, and 100, I always think of quarters, right? So we bring down our 3. 75 divided by 25, there's 3 quarters and 75 cents, right? And then 100 divided by 75 would be 4 quarters. So we end up with 3 and 3/4. I wanted to just do a quick review on that, just to kind of show you we're going to be using those skills. So let's get started with rational numbers on the number line. First thing we might be asking ourselves, what is a rational number? And that's simple. That's a fancy way of saying a rational number is a number that can be represented, let's see, I'll just say, it can be represented as a fraction. So it's a number that can be a fraction, right? So that's a fancy word, but that's a simple way of saying that. So we know if I create a number line here, and I create 0, we know that we could graph 1, 2, 3, 4, and we could say -1, -2, -3, -4. We know that as numbers go to the right, they get larger. We know that as numbers go to the left, they get smaller. And those are things that we've worked on. But what we may not know what to do is would we be able to graph a number if I asked you to graph 3/10? Then it becomes a little bit more complicated, but not impossible. What we know now is, well, 3/10 is larger than 0, so it's going to be on this side, right? It's going to be on the right. 3/10 is less than 1, so wherever I put my 1, it has to be between 0 and 1. And I'm going to give you a hint. If you're going to divide up this number line into portions, I think the easiest thing to do would be look at your number and divide it into tenths. So instead of 1 here, we're going to have 1/10, 2/10, 3/10, 4/10. Got hard to write on this thing. 5/10, and 6/10. So now we know, and if we kept going, we would eventually get to 10/10 or 1 whole, right? Because the fraction with the same numerator and same denominator is 1 whole. So eventually we'd get to 1. So basically we're doing the exact same rules of a number line, but we're making smaller portions. So instead of saying 1, 2, 3, we're counting by whole numbers, we're counting by fractions. And in this case, we're counting by tenths. Now, if I said to graph this number, I hope that you would say, all right, well, it's right there. Place your circle there, your dot, and you're good to go. But what if I said, well, you also need to graph the opposite of 3/10? Well, the same rules apply. Fractions are numbers, right? They're portions of a whole, but they're still numbers. So if we're looking at 3/10 and we say, well, it's 1, 2, 3 spots away from 0 on the right, then we've got to go 3 spots back on the left. And we'll go 1, 2, 3, 4, 5, 6. We'll go ahead and fill out the number line the same way. If this is 1/10 away from 0, how far is this if it's the same distance? It's also 1/10 away from 0. Difference is, it's negative. Whoops, it's not a very good negative sign. It's negative 1/10. We end up with, here we have negative 2/10. Here we have negative 3/10, negative 4/10, negative 5/10, and negative 6/10. So you're doing this number line the same way, but here you have negative numbers, just like you would if they were whole numbers. So if we're 1, 2, 3 tenths away from 0 to get to 3/10, then we've got to go 1, 2, 3 tenths the other direction from 0 and get the opposite. So if we're looking at 3/10, the opposite of 3/10 is negative 3/10. Okay, let's look at some more examples of this. Actually, let's not just yet. Let's look at one more thing on this number line before I move forward. If you look at the numbers we just looked at, 3/10 and negative 3/10. If we look at 6/10, would you say that is bigger or smaller than 3/10? Looking at these two numbers here, you would say 6/10 is greater than 3/10, right? It's farther down on the number line. If you have 10 pieces of cake, you'd rather eat 6 than 3 if you're hungry, right? But going the other way, if we compare negative 6/10 to negative 3/10, it might make sense to say, well, negative 6/10 is larger than negative 3/10, right? But keep in mind, we're going the opposite direction, right? Like, kids used to say, like, it's opposite day, all right? So in this case, negative 3/10 is actually larger than negative 6/10. Reason for that, again, the numbers going to the right get bigger. So 3/10 is on the right of 6/10, so it is a larger number. Negative 6/10 is smaller than negative 3/10. I don't know if I said the negative there. But there you go. All right, let's look at some more examples here. All right. Use what we know about point negative 7/4 and its opposite to graph both points on the number line. The fraction negative 7/4 is located between which two consecutive integers? We'll explain the reasoning. Well, let's take a look at this. All right, let's first get to kind of the easy part, right? We see that each jump, or the difference between each spot here is 1/4. This way we're going by positive fourths, this way we're going by negative fourths, but they're all 1/4 difference. So if it says graph negative 7/4 and its opposite, well, negative 7/4 is right here. We'll put our spot there. 7/4 then would be the opposite, right? Because they're both 7/4 away from 0. for 7/4 here. Okay. Okay. Let's get to this real quick and we'll come back. On the number line, each segment will have an equal length of 1/4 because each segment between the numbers, right, is 1/4. The fraction is located between what? And this is what we're getting to here. Well, if you look at it, we go -4/4, -8/4. Like we know that that's 1, right? So that's -1. 4 goes into 4 goes into 8 2 times evenly, so that's -2. So our fraction, -7/4, is actually between -1 and -2. If we looked at -7/4 and we said 4 goes into 7 one time, there's 3 left over. -7/4 is actually the same as -1 3/4, which we would know is, we'd have 2 and 1. It's right in between. Okay, got some other questions here, and we're not going to have a lot of time on our video, so I'm going to run through some of these fairly quickly. You can come back and look after the fact, and we can also talk in class about them. Okay, the water level of a lake rose 1.25 feet after it rained. Answer the following questions using the number line. Write a rational number to represent the situation. Well, in this case, it would be positive, right? So it would be 1.25, or if we wanted to write that as a fraction, it'd be 1 1/4, right? Rational number just means it can be written as a fraction. It doesn't have to be. 1.25 can be written as a fraction. What two integers is 1.25 between on the number line? Well, if this is 1.25 here, it's between the 1 and the 2, so positive numbers. Okay. Write the length of each segment on the number line as a decimal and a fraction. Well, if we're going from 0, 1, 2, 3, 4, there's 4 spaces or segments between 0 and 1. It means we're cutting them into fourths, which is the same as 25/100, so 0.25. So each segment is 1/4. What will be the water level after it rained? Well, that would be, again, 1.25, because that's how much it rained, above, we don't know that it's at sea level, but we can say that it's above lake level, right? Or it's above the original level of the lake. After 2 weeks have passed, I'm going to erase that just so we can have room to write. After 2 weeks have passed, the water level is now the opposite of the water level when it rained. What will the new water level be? Well, if it's the opposite, if it was positive 1.25, the opposite would be -1.25, or -1 1/4. That is marked here. And so what rational number that is not an integer, whose value is less than, hold on, I got ahead of myself here a little bit. All right, last thing here. It says, state a rational number that is not an integer, so not a whole number, that's value is less than 1.25, and describe its location between 2 consecutive integers on the number line. Well, the answer could vary here, but we could say 1, 2, 3. We could say -0.75. We could say 0.75, right? Both of those have a value less than 1.25. 0.75 would be between 1 and 0. -0.75 would be between 0 and -1. Okay, I know that's a lot of information. This is kind of a long video. We're going to talk more about this in class, but you can always go back and rewind and watch, and we'll go through some examples together. So anyway, thank you for watching.